one of the key terms that we have is for cells or primary and secondary cells. And it's relatively simple. Primary cells are ones that can only be used once until it runs out. Secondary cells are rechargeable and could be used again. And so it's important to be able to distinguish those. All right, so let's find the power for charging the 2-volt battery. Let's say we have, a rechargeable situation, a secondary cell. Let's say that we have a 12-volt source and we have these resistors here and our 2-volt source, and we can find the power charging the 2-volt battery. And so in this case here, as we set up the circuit, that 12 volts definitely going to be pushing current around this way. Even though it's going to be fighting the 2-volt source. And so we've got that coming around. And so why don't you go ahead and solve for the sum of the voltage equaling 0 with using the Kirchhoff loop rules and determine the current. And then from there, we should be able to figure out the power charging the cell, actually battery here. So go ahead and pause the clip, give this a try, and when you're ready to check, you can hit play to continue. All right, so as we come around from this spot, we've got positive 12, going from the negative terminal to the positive terminal, and then negative 2i plus negative 6i plus negative 2i plus negative 2, because we're going from the positive terminal to the negative terminal, and then negative 6i, we should get for our current 0.625 amps. So that's the current going through the entire circuit as we go all the way around. Therefore, in the 2-voltage source, that's how much current is going through. So, how much power is coming from the 12-volt battery, right? We have 7.5 watts is coming from the 12-volt battery. How much is taken out in the resistance? We have a resistance of 16 ohms, and so therefore it's using up 6.25 watts. How much is left to charge the battery there? 1.25 watts is what's actually charging the 2-volt source there. And that should make sense because, the current is going in that opposite direction and recharging it. And then again, if we look at just the current, right, we have the current here, we have the voltage, and that comes out to be the same thing. And again, that negative means that it's charging there. All right, so in this situation, we have a galvanometer here. We have a variable potential divider where we have point A, point C, and point B here, and we have a variable resistor up top, and that's what that arrow going through represent that. And then so when the variable's resistor is sent to 3 ohms, the galvanometer shows 0 current. And we want to determine the length of AC therefore. And we know the dimensions of AC, it's a uniform wire length of 1 meter. It's 4 ohms. And and then we have the situation, we want to determine the length from A to C. And so this is a good one for determining what's going on, kind of using everything that we've gone through here, the potential divider and Kirchhoff's loop rules. So we can set up, just so that we're all on the same page, let's set up the current on the top one like this, the current in the middle like this, and the current in the bottom like this. And we know that there is 0 current inside the galvanometer, and that's going to be helpful for us. So I'm going to have you try this one. Go ahead and pause the clip and see if you can solve this one, and then hit play when you're ready to check. All right, so current 1 is coming in, current 2 is coming in to make current 3, and I went ahead and chose the loops to be like this on the top and the bottom. And for this loop, we've got the negative 3.2, if I have it going around this way, times I1, positive 6, and then negative 4I3, coming through that entire, the entire length right there, that whole potential divider is 4 ohms. And then from the bottom, or from this one, we have negative or positive 2 plus negative Ri3. R is the resistance from A to C, which we're not sure how long that is, and that's what we want to find out. And it says that there's 0 current there, so we know that I3 and I1 are going to have the same current. And that's going to be helpful because we can place that in there. We can actually get the current inside I1. So 0.833, and so whatever you solve for there, it should be current in this direction, I1. It comes, the sign works out, so we know that's what's happening. And we can place that in here and that in there. The resistance is 2.4. And so what's the length then? If this is 2.4 ohms and the whole thing is 4, it's going to be 0.6 meters. And that's exactly where that is at. And so that's the length of that part.